Hello and welcome to our second webinar of our series Advanced Modeling with Allplan Bridge, which will be about templates and data reusage and also Python parts. My name is Dieter Wagner. I'm a bridge engineer here at Allplan Infrastructure, and I'm in charge of consultancy, support and product management in regard to our product Allplan Bridge. Next to me is my colleague Mobile. He's also a bridge engineer, but he's also working as a developer and was involved in the PythonPart implementation, which will be the second part of our webinar. Let's have a look at the schedule that we want to cover today. So I would like to start with a little introduction to explain you the principles and basics of our Allplan Bridge parametric solution. And then we will jump right into the topic, and there will be actually two big parts. So one will be how to reuse data and templates regarding the cross-section, which is one of the major parts of our bridge structures. And the second part will be about the TCL data. So I will explain this more in detail later. So just in advance, Allplan Bridge is database-based program. So whenever you put something in, it's stored in the database, but we can also export this database into a readable file, which we can work in. And this will be the second part of the first part. And the second part, which will be done by my colleague Mobile, will be about placement and Python parts. So this is about how we can add more complex objects parametrically to our bridge model. To start with the introduction, you can see here a simplified circle of the BIM workflow for bridges. And in the outer circle, I will illustrate how the particular tasks are solved within our software. So we are starting with the modeling of the bridge, of the three-dimensional model. As you know, in Allplan Bridge, this will be fully parametric. So I will show you on the next slide what exactly that means. Then we can also add a fourth dimension to this model, which will be time. So in terms of bridges, this is our construction sequence. So this has two aspects. So on the first hand, we can use this for the drafting. So if you also want to have drawings of your construction sequences, you get also this split system in Allplan to make drawings from it. On the other side, it is also it's already a preparation for the next step, which is our static analysis. So when we're doing bridge analysis, it's important to consider the construction sequence and the construction stages. And therefore, this is a preparation for the analysis. When we then actually are performing the analysis, we are putting the loads on it, which is done more or less automatically by the program. The results of this calculation are stresses and forces. And based on these results, we can then do the design checks and the reinforcement, the reinforcement design. And with these results of the required amount of reinforcement, we can then jump into the drawing production in Allplan. And I want to point out that this whole cycle is fully parametric. So let's say if it turns out during the calculation that you need to change the web thickness a bit or the height of the section, you just go back to your geometric model, you change the dimension, you recalculate, and the whole process will be updated. And this is actually covered by three parts of our product. So in the center, we have our CAD platform, Allplan, and Allplan Bridge, like, let's say, a preprocessor for the parametric modeling of bridges and the analysis of bridges. So you will create your bridge model here and then transfer it to Allplan, where you then can produce your drawings and do the reinforcement detailing. Connected to that is also the BIM Plus platform, which is an online collaboration platform for collaboration between project partners or internal company internally. And so you can upload your model there so everyone can view it. You can give tasks there, you can communicate, you can upload files. And this program is also accessible by project partners who don't own the software, right? So even with them, you can communicate via the bridge model. Just to illustrate on one slide the parametric approach in Allplan Bridge, let's maybe start from the other side. How would be the workflow when you do this in a classical CAD platform, also like Allplan? Of course, you can somehow define a 3D spline, an axis, which will be more or less exact, depends on if you can define spirals and stuff. Then you can draw your cross-section as a 2D area, as a 2D object. And then already the problem starts, right? So if you have changing dimensions along your bridge axis, you would need to draw a lot of these sections. You would need to copy them. You need to adjust the dimensions for each position along the axis. And when you have all these sections, then you can position it, place it, and orient it in space. So even if you have a crossfall, this might be quite challenging, and to give the correct angles. And then you can connect them by splines, right? Already this sounds like a lot of work, but even more if you have some changes afterwards, what would you need to do? You could start more or less all over again, because you would need to draw all the sections again and do the alignment again. Therefore, our approach in Allplan Bridge is a different one. Here, the user only needs to create one single section. So it's possible also to create more than one, but let's say the standard approach is just to use as less section as possible. Whenever you have a variable dimension, instead of a constant value, you will define a variable for it. For example, the cross-section height. So instead of the value of the height, I will apply a variable to that distance. And in the second step, I will describe in a table how the height changes along the axis. And then I will assign this table to the variable. And from that, the program can read, you can see this indicated here, at each position along the axis, what is the corresponding value of my section, and will automatically create the corresponding cross-section variant and position it at that place. And in that sense, the user just needs to create one section. You can see here, there's no limit in what part of the section you want to make parametric. It could be an angle like the inclination. It could be the width of the deck or whatever. You simply create a variable, assign a table, and then the cross-section variants are created automatically. And this is the big advantage also if you have changes afterwards, right? You just go back to your one section, you make the slab a bit wider, or you change something in your table, you just recalculate, and the whole 3D model is updated automatically. That's the big advantage of this parametric approach. Now let's jump right into today's topic, reusing data and using templates. So just to elaborate a bit the answer which our colleague here already has given, just modified a bit. Actually, what is the advantage of reusing data? So a first answer might be quite obvious. So of course, it's just simply a waste of time to have repetitive input of data. It will just simply slow down your working process. So therefore, that's the first answer why it is useful to use data that you already have input once before. But there's also another answer to this. And of course, if you already have data that has been used in another project, it's also somehow verified. So you can count on it that it's correct. So your whole work process will be less prone to errors. And the good thing is that to a large degree, all the steps that we show in this presentation, they do not require any special knowledge. They are just accessible for the standard user. However, there will be one part, which is the TCL script language, which will be for advanced users, which we will also touch at the end of the presentation. So let's start with the first big chapter, which are the cross sections, and how we can use here templates and use the cross-section libraries. Before I jump into the issue, let me just explain a bit the data management of Allplan Bridge. So whenever you start a project, it will be stored somewhere on your hard disk. So you can see here the installation and the project folder, and this is actually where your Allplan project sits. And in a subfolder of this, there will be another directory called Bridge, where there is the data of the Allplan Bridge project. So there are actually two databases, one for the Allplan project and one for the Bridge project. And the Bridge database sits in a subfolder of the Allplan project in the standard case. And in the program, you have in the quick access toolbar, you have some buttons which I want to explain a bit. So the first one simply opens the project directory, which you can see here, where your data sits. And let's just have a look at the files. So you can see the first one named here Allplan Bridge ABDB, which means Allplan Bridge database. And this is actually where all the data is stored, which means whenever you put in some value or draw a line, it's directly stored in that database. So actually there's no need for saving in that sense. But there is a possibility, of course this database is binary, so it cannot be viewed or understood or read by the user, but we can make an export of the data in this database to a so-called TCL file. And the TCL file, I will come more into detail later to this. TCL means tool command language. So its first case, it's an ASCII file, so it can be read by the user. It can be opened in every editor. And in addition, as it is a command language, it's also possible to have programming commands there. But we will touch this later. For now, it's just important to understand that we can export the binary data to a readable data, to a data in a certain particular file. And this can be done by these two buttons here. So we have an export button, which will do exactly that. So this will create this TCL file. This contains the whole project data. In addition, there will be a second file, which is an XML file, and this contains more or less additional data. So you could say that all the project relevant data is stored in the TCL file, and the XML file contains additional information like how you set up the layers or other view options, or how you have maybe arranged the superposition of the envelope. So it's not essential for calculation. So whenever you read in the TCL file, you will have your whole project, but it's just additional user-defined settings, you can say like this. And with these two files, which will be explained later, we can also work. But for now, I just wanted to explain to you what actually this TCL file is in order to make it more understandable how we can handle this on the basis of the cross sections. So when we jump back now to the cross sections, I'm here now in Allplan Bridge in the menu of the cross sections, and you can see here a list of the sections that I already have created. The box girder, some pier sections, some sidewalk, some barrier. And now let's have a focus on the barrier, because you could say, of course, this barrier, this could be similar or the same in more or less all of my projects. Maybe it's a standardized section and I want to reuse it. So what can you do? You just right click on the section and you can export this now to a TCL file. In that case, like we've mentioned before, not the whole database is exported into the file, but only the data of this particular section. So it will be stored in the same project path, but it will only contain the data. You can see it's small, only contain the data of this particular section. And now the workflow is quite logical. So to reuse this, I simply go to my new project. I again right click on the cross section menu and say now I want to import a certain file, a certain TCL file of a cross section. And then I just select this one, and then I have the cross section I've previously used in another project also in my new project. As you can see here, this TCL file is stored in the project directory of my previous project. So of course, still I can select it, but maybe it's not nice to have it split. Let's say like in different project where I've used the sections, it's always stored in the corresponding path of the project. So there's more than this, or to make this workflow a bit easier, we have a cross-section library. And you can see here that in the installation directory, there is a folder etc bridge templates cross sections. And this is actually a folder where there are already predefined sections, like we have for the ASHTO, like sections which are often used in American standard. We have general sections, and there are also user-defined sections. So this library can be expanded by the cross-section defined by the user. And the advantage is then you have them available on one place for all your projects. So whenever you export a file, you copy it to here, and then it's accessible for all your projects. And there's more to mention here. So as I've mentioned before, I said the barrier, it could be the same or similar. So what if it's similar actually? Because so it's not about only about standardized section like iProfiles or whatever, but this is the next step. Of course, this section can be parameterized. So I will illustrate this here in this little animation. Let me just quickly stop this. So let's say we have this double T-beam or slab, however you would call it. And now you have another project where you have already created this in a previous project, and now you want to reuse it. But of course, some dimensions are different, right? Then how can you handle this? We have mentioned before that whenever you have a variable dimension in your section, you would create a variable and assign a table to it. So you could say, of course, here in this section, nothing changes. So I didn't create any variables, but that's not the approach that we want to follow here. So the approach we follow here is that we say, still, even if you don't have any variation in a section, create a variable for it. Make the width or the inclination of the slab left or right, or the height of the section, or the distance between the two parts. Define them as a variable, because the advantage is even if the dimension doesn't change, you can quickly adapt it. And this is shown here. So you just see the corresponding variable here in the list. You just type the value in the property window, and in this way you can very quickly adapt the section according to your new requirements. So that's the idea actually of these templates. They are not fixed standardized templates, but they are parametric templates. In this way, you can really powerful work with them. Then there is another part to mention here. These are, let's say, cross-sectional parts, which means I'm not importing a full section which I want to use, but maybe I'm just interested in a sidewalk like here, which I want to use as a part of my cross-section. And to understand this, I want just to explain a bit the theory of these so-called external boundaries, what actually it is. So previously, this implementation was meant to add repetitive cross-sectional parts, especially like stiffeners. You can see here on the right-hand side, if I have a section where I have a lot of stiffeners along the boundary, then of course I could draw each section separately, but of course this would be a lot of work. And so the idea was that I only draw this cross-section once, like shown here, and then I have a function which is called external boundary. So actually we call these lines that set up the cross-section, we call them boundaries. And as it is a cross-section which is not part of the main section, but it's a separate cross-section, which I copy here. Therefore, we call it external. So it's a boundary which is pasted from an external section. And when I do that, you will see this then also in an animation. I just simply select an origin, then I type in the number that I want to have on the offsets between them, and then they are simply arranged along the alignment of this boundary. And even if you come to a corner like this, there is a function which means auto extrusion. So it will always automatically intersect until it cuts the boundary line. We always nicely adapt it to your section. So this was actually the intention. And then we said, okay, that's a nice feature. Why we don't use them also for other stuff which maybe are not multiple, but still they are in a separate section, like a sidewalk or like a barrier. So the idea here is that you, for example, if you have a look now here at the bottom, I have this sidewalk and it's also a standardized section. And as we've seen before, of course, even if the dimensions are changing, I can just by defining some variables quickly adapt it. Then I load it into my project, and then I want to include it into my main girder section. So in that sense, the idea is to draw this sidewalk, make it parametrically, store it in the library, import it, and then just add it to your current section as an external boundary. So this is another application how we can use templates to add additional parts to our main section. And here in this animation, you can first see how this is handled. So I have here just a steel section. Then I click this external boundary function. I select the boundary I want to insert. Maybe let me just quickly stop this. You can see, so they're on the same level. Right here, there's my composite box, and here's my stiffener. So they're on the same level. But now by clicking this external boundary function, I will just select another cross section to be added to another cross section. And now here, I will just type in the numbers. So I want to have 9, and what should be the spacing between them, and where should be the origin. And then I can very quickly add a series of small sections to my main section. And you see, then they are automatically implemented here in the main section. And there's another use case for this. So also quickly stop this animation. Let's say you have here a structure with a certain prefabricated girder, right? And first, maybe it looks like a section that like a standard section, but in fact, this has been set up by an external boundary. So you can see here, maybe if you already have worked with Allplan Bridge, you can see there are no parametric lines here, just these two, which means this whole section here has been inserted by an external boundary. So I've created a new empty section and just added an external boundary to here. And of course, then this will result in a structure like this. But the idea behind this, then I can now quickly change this. Look, if I now follow the animation. So I just click the boundary line and say, I want to change now the external boundary from this type of prefabricated girders to another precast girder, which maybe have this shape. And of course, maybe it's not the same number. So I just change the number and the offset. I recalculate. And in that way, I have quickly adapted one structure to a completely different structure. Also, by just using templates, right? So of course, this could also be just a template that you have again reloaded into your project. Okay, this completes the comments about the cross-section, and now we come to the second part, which is this TCL and XML data. What are actually the benefits of the TCL data? As we've mentioned before, I can export the whole binary database into a readable file. And I can open this file in any text editor, and it will be very easy to understand for the user. You will see some examples later. The simplest way to work in is to copy and paste certain parts, right? So you can work there, modify it, copy paste, edit the values, you save it, and you can import it again, and you will have your project updated according to the changes you did in the TCL file. And it's very nice to work also for the beginner to just use find and replace and to quickly generate a lot of data like tables. Yeah, so I will show you in the next slide what I mean with that. In addition, there is one advanced feature. So as I said, it's not only a text file, but it's a script language. This TCL means tool command language. So you can also, as a bit advanced user, you can also use simple commands by using variables and loops to quickly generate, let's say, a couple of pairs or whatever. And a more advanced thing is the TCL programming, which I will show you at the end of the presentation. There's one more thing, one more benefit about this TCL file, which actually, as you can see, the database of a project, it can grow quite big. You can see here it has about 2.8 giga. And when I export this database into a TCL file, it's small. It's just 1 megabyte anymore. If I zip this, it's even just 50 kilobyte. And so it's very easy to hand over to your colleagues. They will read the file in and they have your whole project available. That's also another advantage of this. Now let's talk a bit about the TCL structure. So let's say now I have a project and I've exported my whole database into this TCL file. Then it will look like this. So I just picked out a part of the TCL file, right? So let's say it structures into particular scopes. So it starts with the project settings, with the materials, and then here we come to the axis. So this, what you see here, is just a part of this script file, which shows the axis definition. Actually, you don't care about all these keywords or terms because it's very easy to figure out the axis definition. It says plan begin. I have a point where I see where it starts. I have a line, I have a spiral, and it's very easy to identify the parameters, and I could edit them also here. Or also the profile. You see, it's just the tangent points, it's the station and the height of the point, and maybe the rounding if you have one. So it's very easy to modify here, to copy paste parts, and then just to save the file, read it in again, and then you have your updated database. Let's have another look at variations, for example. So this is related to our tables. So also here you see there's some command, you just don't care. It's easy to recognize. These are all my table names that I've created. And this is the description of it. And below here, there's the definition of the table. For example, the section height. So I have a line, I see the stations, I see the corresponding value. So I can easily copy this block and paste it below and maybe get the bottom slab thickness from it by just modifying here the values. I store it, read it in again, and I have my updated model. So that's the first idea. What you can do, it's just simply editing. But there's more than this. And you see, actually this structure here, this is not only reflected within the TCL file, but you can also, and this will be our next topic, you can also partially export these parts of the project. So let me explain about this. So when you're going to the backstage menu, let's say the standard setting when you export your project will always be exporting the whole database into one file. But in a backstage menu, you have more options. So instead of the full export, you can have a partial export. And this means that the user can select which parts of the project he wants to export. Let's still say we want to export the full project, but I want to split it into separate files. So you can see that each part or each scope of the project, like project settings, materials, axis, variations, and so on, they will be now all stored in separate files and saved in a subdirectory called TCL, or however you want to name it. And then there will be a master file. Let me go to the next slide to illustrate it a bit more. So again here, I'm in the backstage menu. I have selected the partial export. I select make a master file, make a subdirectory, and export all the partial files. So what would be the result? In my project folder, you can see it here on the right side, there will be created a subfolder, as you have named it here. In this case, it's TCL. And it will now not contain only one file with the full project, but all the partial files. You can see here materials, sections, and so on. And now, of course, you might ask, okay, now I have it split into separate files. Maybe it's easier now to work on because if I want to change something in the variation, I just click the partial file and I can edit it there, so I don't have to look for it. But of course, there's even more than this. But let's first have a look at the master file, because you might ask, how can I now import all these files again? And there will be a master file. It's just like a subordinate file, which has the links to all the partial files. So this is actually the file that you need to import again. So when you import this master file, it will access all the particular files. And in this way, you will have again your whole project re-imported. And the idea about reusing data is that, for example, let's again have a look at the cross sections, right? So let's say you have already a certain set of sections. So we know we have the library, but this is just an example. This is applicable for all the scopes that we have here. You've already set your libraries in a previous project, your sections, and now you want to use them for your current project. So what you're doing, you're making simply a partial export of your old project, let's call it old project of your previous project. Then you pick that file, make also a partial export of your current project, and simply replace this partial file. Then you import a master file, and then you have the sections that you have defined in your previous project also in your current project. As we say, the sections, we have it in the library, but this is applicable for all. It could be combination tables, right? So if you're doing analysis, it's clear the combination to Eurocode, for example, they're always the same. So you do not want to put it in again. So you're just using the file from your previous project, replace it here, read in the master file, and you have all the data available. That's the idea of this partial export. Now let me come to the second part, which is the XML data. As we said, in addition to the TCL file, there's another file called XML, and this contains additional data. So the company, or maybe you on your own, you might have a certain way of how to organize your layers, for example. So when you're drawing a section, you say, okay, my reinforcement should be drawn, this reference set should be drawn on a certain layer, or the boundaries, or the parametric lines, and you have a certain color and a certain thickness of the lines and so on, and you do not want to define this again and again. And this data is saved in the XML file and can, of course, also be reused for your further projects. So maybe you also have an Office standard which says when you're doing analysis reports, you have internal forces, utilization, deformation, and so on. And you have diagrams, and these diagrams are somehow the same in all your static reports. And so you can also simply reuse them again. And just to speed up a bit so that my colleague also can show the Python parts, I would just show a simple example. So this is the XML file, and there are certain scopes where this data is stored. Like here is the data of the layers that we have just mentioned, and you can just simply copy paste this part of the XML file to your new XML file. So I think there's an animation, but it's actually quite simple. So I just copy this at the appropriate position of my new project, or maybe also here the diagram settings. You see, it's not essential that you understand the code. You just need to know the position where it is. So it's always indicated by the scope name. And then I can read in this file, which I have just created. And you see here I have all the diagrams inside. And when I start defining a cross section, I have here all my layers. Okay, then to finalize my part of the presentation, just give me an idea of what advantages there are of using TCL programming. And of course, this is really something for advanced users. They need to learn this script language, which is actually not an Allplan specific language, but it's an open source language. So you can also find this in the internet. And just one example, let's say you have abutments which are similar in all your projects, but of course the dimensions are changing. Then you could prepare and program this as a TCL file. And actually this was done by two TCL files. So the one is very easy understandable for the standard user, and the other file, which I'm showing here, this contains the code, the source code, right? So this needs to be programmed. And then for the user, you will get two files, and then you just simply need to know the dimensions of your abutment, which you can adjust here. Maybe just start the animation because it's shown here. Of course, you need to know the sketch. So you need to know what is the height, what is the length of the wing and the thickness. So these are the values that you can edit before importing. And then it's shown here in this animation. So before you import the file, you just open it. Okay, first he just loads the standard abutment, and then he's editing some parameters because to adjust it to your current project, he saves it, he imports the file, and now he will execute this. You see now the abutment is adjusted to the settings that you have done. Okay, there's one more thing which is shown here in a little animation. This is how you could quickly adapt an existing project to a new project, right? So let's say you just load your old project, you can go to the tables, you change the height of the section, you recalculate, it's immediately adapted. Of course, the same applies also for the peer. Then, of course, a new project has a different axis. You just link in to pin plus, you select the new axis where you want to link the structure to, then you go to the main girder, you just switch to the other axis, you recalculate, and it's aligned along the new axis. It's clear that you can also change the section. You just load it from the catalog, from the library, as you've seen before. So that's also, depending on the project, a very quick way to adapt an existing project to a new project. Now to come to the transition to my colleague, which will now be the second part of the webinar, placement. So it's actually smart symbols and Python parts. This is what I mentioned before. you know that the parametric approach is limited somehow, of course, to, let's say, more or less simple objects, which consists of an area which is extruded along an axis. It's quite powerful, but this is the limit. Now, if I have a more complex object like a street light, of course, I cannot draw this in Allplan Bridge, but of course, it's easy to draw it in Allplan. So the idea was to be able to link complex objects parametrically to the bridge objects, because of course, it's simple to draw the object and put it in Allplan. But what if the axis changes? Then you need to realign the object. So the idea is to have predefined points in Allplan Bridge, and they are linked to the object of Allplan. And when you import the model to Allplan, they will be put on the defined reference point, and in that way, you'll see this on the next slide, they will be parametrically linked. So even if the structure changes due to the reference point, the position of the reference point changes, and the objects are placed then at the new positions. And actually, we have two types of objects that we can use for this. The first one are the smart symbols, and now new in the April version, it's also the PythonPart, and this is a more special part, and this will be now the part of my colleague. So I would like to hand over to a mobile to show us the new functionalities of the PythonParts.
Thank you, Dieter. My name is Moel, and I will be speaking about the placement. As my colleague said, for example, if you have a bridge section like this, and if we want to place the street light across our bridge section, we can use a smart object that would be placed parametrically across our bridge section. So this part is called smart part. So you can see it like this in the 3D. So my question for you is, what if you want to make this 16 lights or this street light different? For example, in this H2, what if I want to change this H2? Like this. As you can see in the slide, the H2 heights vary along the bridge section. So what if I want to make it like that? In this case, I will just edit these objectives 16 times because I have 16 lights. So I will edit them each time. So this brings us to another topic, which is called, in general, or in the beam term, we call these objects. But in Allplan, we call also this one PythonPart. What I mean by PythonParts are, these are of course objects, but they are not just objects, they are parametric objects. They include the elements, of course, and also reinforcements. You can also include functions inside your PythonParts. Functions, I mean section views, drawings. This could also be included in one parametric object. What I mean by that is, I can show you here, I have a pile. This pile, it has a parameter, for example, height, and a radius. You can change it however you like. You also have reinforcement. This reinforcement is also parametric. You can see that I'm changing some parameters, the reinforcement is properly changing. As a function also, I have included the section cut drawing of this pile. So this is also included inside this object, this parametric object. We call this one PythonPart. So today I will be talking about how we can place PythonPart from Allplan Bridge. This is actually a new feature that has been released today. So it's really exciting thing. Before I talk how we can place PythonPart, let me just give you a reason why we need to learn or we need to concern ourselves with PythonPart placement. Let me give you a scenario. For example, let's say I have a bridge model here. I did the model, I did the analysis, and I do the design. After that, I do the reinforcement. After doing my reinforcement, of course, I will do my drawing. But what if I go back to my first step to the model and I make some changes? In this case, I change the height of my piles. Well, in this case, I have to do or redo my reinforcement as well as my drawing again and again. So as you can see, or you can understand where I'm going with this. Like my colleague said, data reusage helps us to remove these repetitive tasks. Of course, the main advantage of PythonPart placement would be also to remove this repetitive task. Another most important part would also be, or reason would be, integrated design. PythonPart helps you to integrate your objectives and your bridge or your model to be integrated properly. So this also increases your efficiency. Of course, this return increases your cost and time. So let's see how we can place PythonPart. course, there are different many ways you can do this. One of them is using just a single point. What I mean by that is, for example, I have PythonPart. This is for the street light, and I want to place it across my bridge here. To do so, I would just place a single point, as you can see on the left edge of my bridge section, and I would place it here. And my street light would be placed across my bridge like this. So this is, like my colleague said, it's a parametrically placed one. But let's see in detail how we do it step by step. First, of course, I have different properties that I can change. One of them being the parameters. Here I will select which PythonPart I would use. In this case, I would use the street light. I would also have the possibility to select where I want to place it. In this case also, we want to place it at every station. So we will just say 1 in this example. We also have the possibility to change the orientation, how it would be placed. Let's say we have this street light and these are the coordinates. Let's say these are the global coordinates when we put this in Allplan Bridge. And of course, this is also our bridge section. If I use the default on my bridge, my street light would face like this. However, I might want to change it. To do so, I can also rotate it a little bit. So in this case, what I did was I rotated my local x-axis to the direction of the global z-axis. So this was achieved by rotating it. As I said before, we have settings for orientating it. So here are the settings, what the settings look like. As you can see here, I have different possibilities or different choices for this setting. As you can see on the list, PL tan, we have C-norm, these are tangent and normal plane axis. I also have the possibility to select the coordinates of the cross section or also the global coordinates. In this case, we want to use the global one, so I will select the global one and I will place it here on this local x direction, the z global, so my light would rotate. Of course, you know by now that Allplan Bridge is parametric, and we said that our Python placement is also parametric. So if I move my point like this, of course, my light should also move without any additional steps required. So this is also one of the main or the reasons why we should concern or we should use PythonPart placement. Secondly, I want to talk how we can place it using 2 pointers. What I mean by 2 pointers is, for example, let's say I have this bracing as a PythonPart and I want to brace my bridge section from these 2 pointers you see. So my bridge would look something like this. But here I want you to notice something here. The first symbol is different than the second one. In the first one, as you can see, you have 2 directions, which indicates to which direction your PythonPart would be orientated. So here also, like I said before, we have different ways of orientating our PythonPart. As you can see here, I have the last 3, which are based on 2 pointers between P1 and P2. Let's have a look in detail what each one of them do. For example, let's say I have stations from 0 up to 20, and I have 2 pointers, P1, P2, at every station. And if I use, for example, P1 and P2, it means start from the current station, P1, go to the next one. So you can see here, if I apply P1, P2, my bridge section would look something like this after applying PythonPart bracing. However, I can also want to change it to maybe to P1 and P2. P1, P2, P, which in this case, the PythonPart placement would also be changed. You can see it in this one. It will be changed to here. And finally, I also have the possibility to change it. This is possible without this change. You can see here, P1, P2, N. This one, the final one, you see the changes. All these 3 different changes that I have shown you here are possible with just changing the orientation. You don't have to do any more complicated steps. So this is also another added feature while placing PythonParts. Finally, I want to talk about how we can change PythonParts parameters. Like I said before, PythonParts are not just objects, they are parametric objects. What I mean by that is, for example, we have this bracing. This bracing is actually second version of the previous bracing, where I have added connections at the end of the bracing. So in this case, I want to place my bracing on my bridge, but like I said, it's a parametric, so I have different parameters. In this case, for example, I have a length parameter. I have also angles of rotation at the start and the end. I also have diameter, plate thickness, plate size parameters for this PythonPart. So like I said, we can change these parameters as well. We can change these parameters from Allplan Bridge. To change them, what we do is we just click on this edit properties, and we will have all the parameters. Let's have a look in detail. As you can see, this one is the total length. This total length. In this case, what I did was I override the total length from 1.2 meter to variable of lsec. This variable is actually a predefined variable. This is, if you have 2 pointers, P1 and P2, you can always get the distance, obviously. So you will use this lsec variable without having to calculate the distance. So this is a predefined variable from Allplan Bridge. However, I might also want to define my own variable. In this case, I defined my own variable, this truss diameter. Okay, someone might also want to just directly input the values. In this case, I know the values. These are 52 and 58. So I will just assign them directly without having to define variable. That's also possible. And so finally, my bridge, this was the default setting here. You can see this was the default setting. If I change the parameters properly, my bracing would change properly as well. So everything would fit properly. So this is also another good advantage. Finally, I want to talk about how we can place PythonPart using just a single point, but at different station. What I mean by that is, for example, I have this reinforcement, the pile reinforcement, and I want to place it in my model. So to do so, I will just use a single point because I have a transversal axis. I will just click one point and I will select different stations. In this case, I want to place it from -6 to -16. So I'm using just a single point, but at different station. Let's have a look in detail how we can change that as well. Like I said before, we have different ways of orientating our PythonPart. In this case, we're just using one single point, so we will just use the P1, P1. Either it could be the previous station or the next station. When I mean by previous station, it will start from the current station and it will go to the previous one. If I use the next station, it will start from the current station and it will go to the next station. So that's how we can use PythonPart. Finally, I want to show you how we can apply this in some real projects or in a demo. For example, here, I have a bridge in Allplan here, as you can see. And I also have these libraries of Python parts. So the same project is also here in Allplan Bridge. You can see the animation, the 3D and the cross section. I want to place Python part. I just click the button and I name it however I like. Here I'll place my point and I will assign the correct. Here I will assign the correct Python part. In this case, the street light. I also want to place it at every station, so I will also indicate or apply where I want to place it. Here I will just update my model. You see, I have 16, in this case 16 street light. This is just one placement. Like I said before, our Python part is parametric. So what if we want to change this height, this H2 height we talked before? To do so, we just click our Python part here, and we just edit the parameters. In this case, we want to edit this H2. I will assign this H2 a variable, this light pedestrian variable. Actually, this light pedestrian is an expression of formula. I have assigned this formula to my H2, to the street light Python part. I will calculate here. I will update my model here. So you can see in the animation that this H2 is being applied. So you can see this H2, the height is varying across my bridge section. Okay, so let's also try to place our bracing across this left section. To do so, we need 2 points because we need the start and the end point. So we will start placing the first one and we'll place the second one. Here, the first one changes, like I said before, because it directs us to the second point. Here, I will select my PythonPart, the proper one, in this case, the bracing, and I will assign the proper variables. Here, I'm going to use this lsec I said before to get the correct length, and I also use just direct values. I will also change my orientation a little bit. And finally, I want to place it, I want to indicate where I want to place it. In this case, I want to place it at every station. And I will just update my model here. You see, first the Python parts are placed, then the correct parameters are assigned. You can see first the lights are blinking because their parameters are being changed. And secondly, you can also see in the plan view, the bracing are changed because their length is being changed, or their length has been assigned another value than the default value. So you can see my bridge section has been updated properly. Here you can see the bracing and the connections as well at the end being properly placed. And of course, the big issue is what if we change something? Here, let's change our axis or the curvature of our axis. You can see it here also in the bridge. Everything has been updated properly. But also I want to change my super elevation, the cross section. Here I would add some super elevation. After making a change in my bridge, of course, I will have to calculate it. So it will be calculated properly. And here I would just have to update it. And you see, immediately it updates. And of course, like I said before, the Python parts are first placed. Then the proper parameters are being changed as well. You see the blinks, it means the parameters are being updated. Like we said before, this is possible because our placement is also parametric. You can see the bracing being properly placed. You can also see the lights have been moved as well. So everything is parametric. And finally, my average parts reinforcement. What if we want to place reinforcement as a Python part? Here, I would also use just a single point, like I said before. And I would select, of course, the correct Python part. In this case, the pile reinforcement. You can see I have all these different parameters, but for now, I will just edit this height and the radius of my pile reinforcement so that it would be the same as my models. And here, I will also select the proper orientation for this pile reinforcement. I will also provide or indicate where I want to place my pile reinforcement from which section. Here, I would just update my model. As you can see, it has been updated properly. You can also see my reinforcement has been placed. Like I said before, Python parts are parametric objects. Like I said, you can edit them from Bridge or you can edit them from Allplan. Here, I'm editing it from Allplan. I'm also adding, like I said, functions, in this case, section drawing. So this all is inside one object, the drawing and also the reinforcement. Here you can see I have prepared also bar schedule and some section drawing. And what if I make some changes? Like I said, parametrically, everything is updated. So let's change our pile height. I will add 5 meters. So it will be 15 meters. I will just calculate it here. This was the previous drawing. I will just now go here and update my model. You can see my model has been updated properly. You can also see the model or the pies height has been changed, and you can see here the reinforcement has also been changed. You can see it's 15 meters here. You can also see the bar schedule has been updated. It has taken the 15, and everything is properly updated. This is my final slide. Thank you.
Super. Well, thank you very much. So I just want to thank you for your attention and give you some final remarks. So if you have any question regarding the topics that we handled today or any other issues, please just contact us at office@allplan-info.com or also directly support at allplaninfo.com to our engineering team, and we'll be happy to answer them. And one final remark, don't miss our next webinar of this series. So it will be on June 16, and it will be about the challenging thing, so that how we can use Allplan Bridge also for other infrastructure projects, so not only bridges. So be surprised what comes up here. So thank you for your attention and hope to see you again in the next webinar. Have a nice day. Bye bye.